Hello, this is Jeffrey Fox again. We're resuming the Big Data Software and Projects course of the Data Science Certificate. In this short lesson, we'll be discussing some background or context for our work in terms of the current status of big data in the real world. Here's a famous graph which gets updated each year. It represents the total amount of data in the world. And we're somewhere around here at around 6 zettabytes or so. And a zettabyte is actually a pretty big number. One way of noticing it, it corresponds to about a terabyte per person in the world. And another critical feature of it is it's consistent with that, namely the reason it's so big is there's just a lot of people, is the estimate that 2/3 of this data is created and consumed by consumers. Video, YouTube, Facebook, image sharing on Facebook or Snapchat and things like that. This size measured in zettabytes should be compared to the largest science application, which is probably the data from the Large Hadron Collider at CERN. And maybe there's 100 petabytes or around within a factor of 2 there. And this is 4.025 fraction of this total of 4 zettabytes. But actually is even, well, that was the total in 2013. But this points out that when we look at these important science applications, the amount of data there is big. It's big data, but it is not the biggest data. But of course, quality is better than quantity. So it is high quality, incredibly important big data. Here's just a comment on trends in the world. Here's the total cloud traffic, which we notice is measured in zettabytes per year, actually thousands of zettabytes per year. And we see, as is a known important feature of the world is getting more and more mobile driven. And currently the mobile fraction is not enormous, but it is growing faster than the total. Here is some statistics on sort of the various devices in the world. TVs at 5.5 billion are sort of the highest, but they're being chased by mobile phones and smartphones. The smartphone, as it gets lower in price, because Moore's law is making smartness cheaper, that is, of course, one of the fastest growing part of the mobile phone market. Here we have laptops and desktops, and if you follow the news, you will notice that laptops and desktops have actually decreased recently. They've actually slightly recovered at the moment, but still they're not. They're sort of not today's growth area. Tablets are growing, and there is some disagreement here as to whether this growth is going to continue. Even if it doesn't continue, tablets have burst into this large size faster than any other device. They really exploded very recently with the iPad introducing this new idea. Tablets are now somewhat declining because of two features. One is smartphones are getting more tablet-like. There's things called phablets, which are somewhat between smartphones and tablets, namely they're big smartphones. And also tablets are sufficiently expensive that people don't replace them every year. They keep them for a while. Here is a sort of graphic describing how each generation of computers gets bigger in size. I started my interest in computing in the early 60s, and then we were talking about one machine a city or something like that. I was at Cambridge in England, And I'm not certain we had initially, when I started, more than 1 or 2 machines sitting in the computer department of the university. The machine I used was called EDSAC, a very old machine with paper tape and trivial performance and things like that. And of course, it's well known that people thought that such few machines were all you needed. Watson from IBM made a famous comment that only a half a dozen machines were needed. Then here we have digital's revolution, the mini computer, the PDP, and VAX. Digital, of course, didn't actually keep up with this trend and disappeared. Then we have PCs at hundreds of millions, the desktop internet, and then finally the mobile internet. So each time you see it's carefully designed to be around a factor of 10 increase in size. Million, 10 million, 100 million, billion, 10 billion. And here we are, we're sort of sitting here now, starting this revolution. I'm sorry, I got a cold last night. And another important thing to remember is that Moore's law is creating this effect because Moore's law makes a device of a given capability cheaper because it's smaller. That can be created, that can be realized in terms of a fixed size device and making that device more powerful. That's multi-core machines with lots of cores. Or it can be used by taking the same size CPU and putting it into smaller and smaller devices. That's the Internet of Things and the smartphone revolution. Here we have the start of a few slides describing the change from a real world to a virtual world. Here we have physical music, CDs, I guess cassettes if you like. Here we have digital tracks, downloads, and here we have streaming. And at least last year, streaming was jumping in popularity. Digital tracks declined a little, and physical sales, which is already at a small number, 172 million, compared to 1.3 billion here and 118 billion here. This one is declining 13%, the physical per year. So this stresses the changing world we live in. That's seen again on the next slide by something we call no more mouths. Namely, I surveyed in my class last semester whether the students thought that shopping malls will survive. The class was split. If the ones that thought it would survive actually only thought it would survive in a different mode where it was focused on its interaction capabilities, people-to-people interaction capabilities, with the electronic model still being in the critical sales model. This particular chart shows closings in various well-known chains, Barnes & Noble, that's books, Staples, that's supplies, GameStop, maybe that's video games, Gap, Abercrombie & Fitch, Aeropostale, those are clothes. And of course, JCPenney is all the general department store, including clothes. And you can see these are all the number of closings in the 2011 to 2015 period, or maybe a little longer here, 2019, and points out that retail stores are not necessarily a growth area. And this is an important trend, of course. It means that all these companies have their own must have their own electronic form as well as their physical form, and the only chance of surviving is to have actually both. But you can either be purely electronic or have both electronic and physical. And you can see Amazon, which started off purely electronic, is with depots and things like that becoming somewhat physical, at least slightly physical. This is, of course, where people are going. eBay, Amazon, in China, they're all going to Alibaba and so on. This is a pretty interesting slide to me. It shows you the fraction. And let's just look at the estimation for 2020 because they're the numbers are biggest, and so we can get more excited. 65% of media, etc., sales will be online by then. It's actually around 50% already. Electronics are estimated here at 50%. Even furniture, it sort of amazed me to see the furniture was up at 30%. Maybe that's because real furniture stores just can't have enough stock to be competitive. Clothing is 25%, and I can see from it's clear why that's still. I mean, one of these some of these trends are actually accelerated by the increasing power of the deliverers like UPS and FedEx. Because now with clothing, of course, you can't try the clothes on electronically, but you can return them very efficiently. And so this clothing stores have realized that online sales with very convenient, rapid, easy to do returns if they don't fit or you don't like them is an extremely effective way of selling clothes. Here we have health and personal care, not so much, and food and beverage down here near zero. And this plots similar features. This is the size of the total offline retail sales in green, and here's the online in blue. And so it looks as though offline totally dominates, which it does. However, look at the percentage increases from year to year. Here is the offline retail increase, which went, of course, negative in the recession. Here is the online, which actually stayed just about zero in the recession, and is now up there at 18% per year. And of course, it started off even growing faster. But you can see where the growth is. 2% versus 18%. It's obvious where you're going to get the most reward for your innovative dollars spent. And this again, the question is, how is this going to go? Is this blue thing going to sit here at about a third of the total, or is it going to grow to be bigger than the offline component? This plot shows the total again. We actually sort of had that in the previous plot, and you can see that the e-commerce sales are currently 5%, and obviously growing faster than the total up here. Here is even a plot suggesting that groceries are actually taking off. They're still pretty small, but compound annual growth is 3% for offline. That's compatible with the total retail, and online is 21%. Actually, slightly bigger if you remember. I think we've estimated 18% for the total online market is compound annual growth. So groceries are not, which are currently absolutely dominantly offline, because you tend to need, when you go out to buy something, you need it now, not 2 days from now. So that's there have been these exciting predictions, which I think are just possibly just publicity of using drones, but that was news from Amazon. We'd have Amazon drones just delivering to everybody automatically. But more realistically, you can just have local companies and local dumps that allow you to order online and get delivery. We know that, of course, for pizza already today. So that's the end of that section, and we will continue in part C of this unit. And at this stage here, we will close and wait for you to take a look at the next